Hello everyone and welcome to another video. Now we previously tested Nvidia's small form factor RTX A400. This is a workstation card that gamers will probably want to avoid, especially at around £150, but it can still put out respectable figures in lightweight and esports titles. I got a lot of comments under the previous video asking for a comparison to this AMD's RX 6400. Both cards have 4GB of GDDR6, a 64-bit bus width and 768 cores. Neither of them require additional power connectors, and the Sapphire 6400 I've got here also comes with a standard height and low profile bracket, just like the A400, so they're ready to be used in a standard or smaller form factor machine right out of the box. The A400 has 8 PCIe lanes, whereas the 6400 has 4. Myself and many others have expanded on this in the past, but the bottom line is that running the 6400 in a PCIe 3.0 system or lower can noticeably impact the performance. By how much will vary on a game-by-game basis. For the initial on-screen footage, I've compared both cards in best case scenario mode, and that is running in PCIe 4.0 mode as part of a modern 14th gen Intel system. I'll then be talking about how the cards compare in PCIe 3.0 mode for those of you with older machines. Let's start with our PCIe 4.0 comparisons then. I've paired the cards with an i9 14900K, which has been limited to 125 watts, so it performs more like a 14700K. I am using the latest game-ready driver at the time of this video, 560.94 for the RTX card, and Adrenalin 24.7.1 for the RX GPU. So let's start off with Fallout 4, 1080p with a high preset and TAA. With the RTX A400 we saw 49 FPS, a 1% low of 37 and a 0.1% low of just 15. The RX 6400 pulled way out ahead in front with 74 FPS on average, a 1% low of 59 and a 0.1% low of 23. For Cyberpunk 2077, 1080p with the lowest settings here, the RTX A400 hit 38 FPS, which I don't actually think is too bad considering we are using native 1080p resolution, no FSR or DLSS here. Of course the RTX A400 can utilise DLSS and it can also utilise ray tracing, which we'll talk about briefly later on, but in all honesty ray tracing isn't something you're going to want to enable with either of these cards because you're going to have to make some pretty big graphical sacrifices in terms of resolution mainly. Anyway, 1080p with the lowest settings, the RX 6400 board head once again, 50 FPS for this card, a 1% low of 40 and a 0.1% low of 34, which again I think is pretty decent for this low end or entry level offering. The game still looks pretty decent with the lowest options. I wasn't expecting much from Starfield to be honest, so I set the graphical options to their respective lowest. The RTX A400 managed just 19 FPS with a 1% low of 15 and a 0.1% low of 14, so not a great result by any means, but it was consistent. If you're looking for a positive in those results there, at least it was fairly smooth. I mean, it was bad, but it was consistently bad. The RX 6400 actually managed to hit 30 FPS with a 1% low of 24 and a 0.1% low of 23. With a little bit of FSR enabled as well, it's going to run a lot better. In these side-by-side comparisons, I tend to refrain from using any form of upscaling, of course, to give you a better idea, a more fairer test in my opinion, but there we go. Elden Ring is of course capped at 60 FPS by default. We don't have to really worry about that with the RTX A400 because it's going to achieve just 37 FPS on average with a 1% low of 33 and a 0.1% low of 30. Again, it was a consistent experience, and because we're seeing at least 30 FPS, I'm going to consider this playable for this GPU. The difference between medium and low settings isn't actually that noticeable in terms of a frame rate. There may be like 1 or 2 FPS more at low, but the game looks a bit better at medium. So this is where I kept things. The RX 6400 did manage to hit the 60 FPS cap. 60 of course was the average, the 1% low was 56, and the 0.1% low was 50. As you can see, both cards are really doing quite well in terms of the power consumption as well. You'll often see them sitting at less than 50 watts. Red Dead Redemption 2 next, 1080p with the ultra textures, which both of these cards do allow for. Everything else was however set to low, and TAA was enabled and set to medium. The geometry LOD was set to max, and the grass LOD was set to 2 out of 10. We have 37 FPS on average for the RTX card, a 1% low of 33 and a 0.1% low of 32. Again, pretty consistent. But the RX 6400 definitely offered a more enjoyable experience, and we could certainly afford to bump the settings up a bit if we wanted to. 67 FPS was the average, the 1% low was 55 and the 0.1% figure was 38. Finally then, with the PCIe 4.0 results, we have Cyberpunk 2077 with ray tracing enabled. Everything else is still set to its lowest, but RT is set to on and slash ultra. With the RTX A400, 8 FPS, a 1% low of 7 and a 0.1% low of 6. Not worth enabling unless you're going to enable some really aggressive DLSS. The RX 6400, 7 FPS, 6 is that 1% low and 5 is that 0.1% figure. So the RTX card did pull ahead, but it's not worth enabling RT on either of these unless you want to turn it into a blurry mess with DLSS or FSR. But that's it for the gameplay footage. I want to talk about the PCIe 3.0 results now, because as you know, the 6400 will perform a lot worse in PCIe 3.0 mode. In fact, the change in figures is more noticeable with the RX 6400. I mean, the RTX A400 is a PCIe X8 card, and when you run it in 3.0 mode, the differences in frame rates aren't that significant at all. Though, as you'll notice, the RX 6400, despite the change in performance, will still pull ahead the majority of the time, bar one result. So for Fallout 4, PCIe 3 mode now, same settings, the RTX 46 FPS on average, 1% low of 34 and a 0.1% low of 15. The RX 6400, 65 FPS, a 1% low of 52 and a 0.1% low of 22. Cyberpunk was the aforementioned result that actually did better on the RTX card. This game absolutely hates the 6400 running in PCIe 3.0 mode. It does not like the limited PCIe lanes, the limited bandwidth. It just falls apart. I mean, 33 FPS was the average for the RX card, and the percentile figures didn't fare very well either. As you can see though, the RTX A400 is pulling ahead by 1 FPS, 34 here, and the frame times were a lot more consistent too. The 1% low was 27 and the 0.1% figure was 25. With the rest of the results though, pretty much as you would expect, the RX 6400 still pulling ahead, the RTX A400 in Starfield next, 18 FPS as an average, 1% low of 15 and a 0.1% low of 14. The AMD card 28 FPS, 22 as the 1% low and 21 as the 0.1% figure. Almost playable, but not quite on this card. Elden Ring, still capped at 60 FPS by default. The RTX card, 35 FPS, 31 as that 1% low and 30 as that 0.1% number. Still playable in my opinion. The RX 6400, again, still playable. Couldn't quite maintain the 60 FPS cap here. 58 was the average. A few more dips and drops were noticeable here. 49 was that 1% low and the 0.1% number was 35. Red Dead Redemption 2 next. The RTX A400 still doing okay with 36 FPS on average, a 1% low of 32 and a 0.1% low of 31. The RX 6400 still doing better, of course, 55, so we've seen a bit of a drop in terms of the average. The 1% low was 44 and the 0.1% low was 29. So if you're sticking it in an older system, it's still going to do all right. And we'll finalise with ray tracing yet again in PCIe 3.0 mode. This time the RTX A400 is pulling ahead with double the average frame rate, 8 compared to 4. I know that doesn't mean much at all. In fact, that 0.1% number was tripled with the RTX A400. But you're still going to need DLSS mode and ultra performance, or FSR and ultra performance, and at that point, it's going to be a blurry mess and not really worth it. But there we are. I think you probably knew what to expect going into this. We have a non-gaming card versus a gaming card. They do cost similar money, and I thought it was interesting just to see anyway how well these two did and how they compared. Hopefully you found it interesting, but as always, I encourage you to leave your thoughts in the comments section below, and I hope to see you all next time.